So in section 1.1, our first section, we have identify points, lines, and planes. But to begin geometry, we first have to look at our undefined terms. And these are three things that we start with. We don't have a formal definition for them. That's why they're called undefined. But we've just kind of accepted that this is what they are. This is the very beginning of the process. And anything else we do from now on will be based off of these three terms and what builds upon them. So we first have the point. Now a point has no dimension, and we're just going to represent it as a dot. Typically when we do a point, we do a capital letter with that, so I would say that is point A. Capital letter, if I had another point, I could have called it point B. Again, no dimension, it's just a point. Now a line though, a line's going to have one dimension, so it goes off in one direction. It's always a straight line that we'll have. We put arrowheads on the end, and when we go to name a line, we can either use a script letter and call that like line L, or I put 2 points on it and use 2 of those points, and I could call it line AB. So capital letters with the arrows on top, or I could call it line L, or I could even call it line BA. And when we put like AB and BA here, we're saying those are the points that it goes through, but we want to think of those arrows, meaning it goes on from those points on forever. Our third one is a plane. Now a plane is a flat surface, so if we think of like a piece of paper, or your computer screen, or a wall, or a floor, that's a flat surface. And that has 2 dimensions. It's like a plane. It goes on forever, but we can't represent it that way. It's more of just a conceptual thought we have. And typically it's drawn to show a little dimension. So we may draw it like that. Now, we can have points on a plane. And to name it, if we think about it, a point has 1 letter. A line will have 2 letters. A plane needs to have 3. So I could call that plane A, B, C. Now another way to identify a plane is just to give it a capital letter, and when we typically do that, it doesn't have a point, so we definitely don't want to think that. But if we're talking about multiple planes, it's a lot easier to say, oh, here's plane M, here's plane N, here's plane P, instead of naming all the 3 letters. So this is a 2-dimensional flat surface. So there's our beginning. So from here on, we just build upon that. Or maybe we just start looking at specific cases of some of these. For example, collinear points. Now these are points, we know that. And if we think of collinear, we see the word line in there. These are going to be points on the same line. So if I draw a line, and put some points here, I could say that A, B, and C are all collinear. Now, D is not on the line, so D is not collinear. So maybe the question asks, which of these points are collinear? A, B, and C. If they asked you if A, B, and D were collinear, that would be false because there'd be no line there. Now, just in case they try to play tricks on you, what if I had point E out here? Now it looks like that line could go through and maybe go through E, but we can't use looks like as a reason. So if we're not for sure, we're not going to say that it's collinear. Even though we'll put slash through these, they're not collinear. Okay, same idea with now coplanar points. They're going to be points on the same plane. So if I draw a plane, let's do F, G, H, and then I is out here. I is not on the same plane. F, G, and H would be coplanar if I want to draw a plane in this form and put some points there. Then I have this other point floating through space. It's not on the same plane, so they're not coplanar. Again, looks like, doesn't work as a reason. We have to have them sharing it. So let's start looking at naming some things. So give 2 other names for PQ and plane R. If I look at PQ, that is this line right here. So I need another name for it. Well, it's really easy just to switch the 2 letters and call it QP. because those are still the 2 points that goes through. I just switched the order I wrote it. Now, another name, if you notice the lowercase n here, that's attached to the line, so we're going to call it also line n. We should probably put a line n. Now we go to plane R. Let's identify here. So plane R, we need 3 points that are on the plane. So let's see, I could do VSP as the name of the plane. I could do VPT as the name of the plane. I could do VST as the name of the plane. But I actually can't do SPT. This one doesn't work because they are collinear. And if we jump back to a plane, then when we name it, the points need to be non-collinear. So at least one of the points can't be on the same line. And we get that because if you look at this picture here with SPT, they all line up on the same line. And I could take that and draw another plane from there. Let's say I just did one in blue here. And now SPT lines up on that plane. Or I could do another one. And it's almost like pages of a book. Each one would be a different plane as it goes around. And we can't do that, so we have to be careful to make them non-collinear. Alright, part B. Name 3 points that are collinear. Well, we just mentioned that S, P, and T are all collinear. They're all on the same line. Now 4 points that are coplanar, all on the same line. We could say S, P, T, and V. Alright, moving on. We start looking at a defined term, and this is again using our basic undefined terms. We start to build upon that. And our first one is a segment, or a line segment. And this has endpoints on the line that has the line end at those points. So before we said, alright, a line has arrows, it goes on forever. A segment stops. So if I took that line and now I have AB and it stops, it's going to be a defined length. And so it doesn't have arrows, so I write the 2 endpoints and then the bar on top with no arrows. Let's think again. We had earlier line AB and it went through A, it went through B, but it kept going on and on and on. So now in a segment it ends, it kind of cuts off. Now what we're going to notice later on is we can measure a segment because we know it starts at one point, ends at another. We could also flip it around and call it BA. Again, those are just our endpoints, and we'd be fine with that. Now, array is kind of the combination of both. We said we had a line, but what if we had one endpoint and one point that it just went through? So let's write A and B here. So this is array. I don't have an arrow in both directions. I have the arrow in one direction. And if you think of like the sun's rays, so if I had the sun here, a poorly drawn sun, the rays come out from the sun. They come out in a straight line. They started at a point and they keep going. So an array, it starts at A and it goes through B, and I'm going to draw it to show that when I label it. So it has no arrow over the A, there's no arrow through there, but an arrow over B because it keeps going. What you'll have to be careful with, though, is that is not the same thing as this. In this case, it starts at B and goes through A, and that would be the ray. So we have to be careful in that it doesn't have the same point and doesn't keep going. Okay, now we have opposite rays, and this is going to be when we have a single point and then our 2 rays go out in opposite direction. Kind of again like our rays of the sun. Let's draw a poorly drawn sun here again. So the sun shoots light out in all directions, but let's say 2 of them go in exact opposite directions. Well, they both start at B, but the one on the left goes through A, the one on the right goes through C, and they're opposite rays. So one thing you have to pay attention to is they share an endpoint. That's important. They have to have the same starting point, endpoint, and they're opposite of each other. They actually also form a straight line if we look at it. So I could even say that line AC is that combination of the two. Okay, now we're going down a couple examples here. Give another name for GH. First thing I notice about GH is it's a segment. So it has endpoints. And if I just flip it around, I could call it HG. Now, name all the rays with endpoint J, and which of these rays are opposite rays. So going around, I could start at J and go through E. I could start at J and go through H. I could start at J and go through F. And lastly, I could start at J and go through G. So there's my 4 rays. They each go out in the opposite direction. I'll save you the drawing of the sun again. Now, which of those are opposite? Which of them form a straight line? Well, let's pick one. Let's look at JE. Now, JE goes in the opposite direction as JF. Together, they form that straight line, EF. Now, JH and JG also go in the opposite direction, so they would also be our opposite rays. So let's keep adding some more tools that we're going to need. So intersection of lines. If I drew 2 lines and they intersected, they would meet at a point. And that's important because we're going to need to know that lines intersect at a point. Not 2 points. Not anything else, a point. So I could say, maybe, let's call it L, M, and point A. I would say that L and M intersect at A. Think of the street. As you're driving down the street, the two roads meet at an intersection. Now, if you think of those 2 roads as lines themselves, they come up, they meet at one point. They're not going to come cross back over. They're not going to be some street coming out of the middle of it. The two lines, the 2 roads meet at a point. They intersect there. Now, intersection of planes. If I had 2 planes intersect, where are they going to meet? Now, you're probably sitting in a room right now, and if you look at the floor and you look at the wall, they meet at a line, and that's that line where the floor and the wall meet. You look at the ceiling at a wall, and when they meet at that corner up there. So that's going to be the intersection of planes. Let's just say planes intersect at a line. One line, not 2, not multiple, a line. So let's say I have plane M and plane N. They're going to intersect at line L. I could use points there to name the line. I could use just use that letter to identify it, and we'd say that plane N and plane M intersect at L, line L. Now, let's kind of generalize it here. I had 2 lines meet at a point. So in my undefined terms, the 2 lines met at the one previous to it. I have 2 planes meet at a line. So the 2 planes, the third one we talked about, met at a line, the one prior to that. Now, we're not going to have points intersecting anywhere, and we're not going to worry about something intersecting on planes, but we just want to think, where would they intersect? And you can always use the roads as an example for the intersections of lines, and you can use the walls and the floor as your intersection of planes. Okay, now a few examples to do. So what you should probably do is pause the video, try to draw these out, and see if we get something similar. So sketch a plane and a line that is in the plane. So I'm going to draw a plane, and a line that's in the plane. So it's almost like I'm looking at my piece of paper and I have a line drawn on it. Okay, that's a pretty basic one. Sketch a plane and a line that does not intersect the plane. So we want to think of a line that wouldn't be on it. So maybe it looks like that. Could be out here. Could just draw something out there floating through space. Sketch a plane and a line that intersects the plane at one point. So maybe I want to think of this as like a flagpole. When you look at a flagpole, it's a line that comes in and hits the ground. So I could have this line come here, hit the plane, but then it keeps going. So I'm going to put a little dashed line and draw it through. Let me try it over to the side a little bit better. So here comes my line. It hits the plane. We then have our dotted line from there, and then it keeps going. Okay, sketch two planes that intersect in a line. So let's draw, I'll change colors here. And have one plane here. Now if you're not sure, just think of that floor and ceiling or the wall and the floor. You could draw it like that. And there's my line where they share. Or if you want to get fancy, you can draw one plane and the other plane, and they intersect on the line. Okay, sketch two different planes that intersect a plane, or two different lines that intersect a plane at the same point. So, I need a plane. I need some lines. We'll say one line comes in this way, hits the point, and then keeps going. The other line comes in the other direction, hits at the same point, keeps going, and there's my two lines that intersect a plane at the same point. Okay, a few examples, but good again. Pause the video, try these out, and see if you're getting the same thing. Give two other names for WQ. I can flip it around, QW, make sure I leave it as a line, put the arrows on top, or it could be just simply lowercase g because that's the name of the line. Give another name for plane V. Well, they use just that capital letter, so I need to use points. Now let's think, points that are on the plane. I have R, Q, S, and T. But I have to be careful they can't be on the same line. So I can't use R, Q, S together. So I could use maybe R, S, T. I could use QST. I could do RQT. Any of those would work. Now, name 3 points that are collinear. Then name a fourth point that is not collinear to those points. Well, like we just said for the plane, the 3 points that are collinear are Q, S, and the one that is not is T. Okay, number 6 here, name a point that is not coplanar with RST, which is not on the same plane, not on the same line, but this time it's not on the same plane. Well, other options would be, well, G isn't a point. W looks like our best choice. Now, at number 7, it says, is point W coplanar with points Q and R? If we look at Q and R, they are on the plane. W is not. So you'd say it's not coplanar. It's not on plane V. You could go on and add that W is collinear with Q because it's on that same line, but we do not have a plane. Moving down, number 8, another name for ZY. If we look at ZY, it's a segment, so it's just this portion. So I'm just going to flip it around and call it YZ and keep my labeling the same, bar on top. Name all rays with endpoint V. So that's anything that starts at V and goes through W, starts at V and goes through Y, starts at V and goes through X, starts at V and goes through Z. Name 2 pairs of opposite rays. So I could say VX and VW would work, or VY and VZ. The last one, give another name for WV. Now this one we got to be careful on. WV. is a ray. It's a ray that starts at W and goes off permanently, infinitely. Now, W has to be the first point because it's still the start of it. But it goes through V, and it also goes through X. So if we call it WX and put the ray arrow above it, it'll still work. We're still good. That's still a ray that starts at W, goes through a point, V and X, still on the same line, and then goes on infinitely.